Magic News with Sam.
All right, class. Well, welcome back to Chemistry Minutes with Mr. Rink. And today we're going to start. We're talking about stoichiometry again. A reminder, of course, when we look at stoichiometry, first we should really look at it's the measurement of elements. And the first thing I want to remind everyone is the pathway, and we need to write this at the top of our page. Remember, you can always put pause, slow down, you can always rewind, you can always do more examples, and whatnot. So what we're going to do is we're going to remember that we always, usually at least, we start with grams, say, of A. Now, not always, sometimes we're given moles of A, but most of the time we have grams. Alright, so you need to convert that to moles. I think most of you know that. Moles of A. And we're going to do that by dividing by our molar mass. So that's just a reminder. Once we're in moles, and this is the thing, you have to be able to recognize we're in moles. Then we can do stoichiometry, and stoichiometry is a fancy word, but really it's a ratio of moles over moles. It gets us from one place to another, and when we come out of that, we're in moles of B. Moles of something completely different. Sometimes we want to stay there, and then a lot of times we go back to grams. But now, instead of grams of A, we're in grams of B. And in this case, we would multiply by the molar mass. So we need to keep this whole process in mind. Where are we on the process? And where do we need to go? So a very basic problem we could start with would be something like we have 10 grams of water. And by the way, we always need a balanced chemical equation. 99% of the time they're given to you in the problem. Let's say they're not given to you in the problem, then you need to balance it. But like for in this case, we have 10 grams of 10 grams of oxygen. Sorry, and we want to know how many grams of water can be produced. Classic problem. So I always like to go to the equation. First of all, what are we trying to find? And I like to circle what I seek. And I like to write in there question mark grams. How much water am I trying to find? And then from there, we also want to box what we know. And in this case, luckily we don't have to find the limiting reactant yet. We have 10 grams. So I'm going to box that and say that I have 10.0 grams of that. So I have 10 grams of oxygen. Now look at the ratio. It's a 1 to 2. 1 oxygen for 2 water. So that's going to be important. That's going to be our stoich. So sometimes students get stuck of where to start. You always start with your limiting reactant or what you know. 10 grams of oxygen. Again, looking at our map up here, we need to now divide by the molar mass. So we're going to go times in a line. Don't forget, we always do that. It's called dimensional analysis. Fancy word, but really just means we're going to either multiply or divide. Again, just from the previous videos, we need to recognize to do our units first. Whatever's on the top is going to go on the bottom. So it's an automatic transfer that you guys need to get used to doing. And so we put grams of oxygen on the bottom, grams of oxygen on top, so it cancels, of course. And we're going to moles. We had a previous video how to convert from grams to moles in case you need more work with that. Oxygen's molar mass, if you look up in the periodic table, 32 grams per mole. 16 on the periodic table, but there's 2 oxygens, so 32. So if we were to stop there, now we always want to do this in one calculation. I know it seems complicated, but it reduces rounding errors. So now if we were to stop, we're in moles. What's our map say to do? Our map says now that we're in moles of A, we need to do the stoich. Again, I say this a million times, we always start with our units. So moles over moles, it's an automatic thing you do. What's on top right now? Because once again, you want to recognize whatever is on top is going to go on the bottom. Alright, and I'm doing this in red because so moles of oxygen is on the bottom. And what are we going to? Well, let's go back to the problem. We're looking for grams of oxygen. So we need water, so we need moles of water. What's my ratio? Okay, now this is an important one. coefficient 2 by water, so 2 by water. 1 by oxygen, 1 by oxygen. Say you steal them and notice units are canceling because what's on top is on the bottom. And then if we wanted just moles, then we'd be done. But we want grams. So one more step. Again, do your units first. Moles of water on top. So moles of water on the bottom. Notice the colors. Notice how it works every single time. It's the same way. We write in our units first, and we want to go to grams of water. 1 by mole always. Molar mass of water, 16 plus 1 plus 1, 18 grams per mole. Now it's time to do our math. Sometimes people get all stuck by this, but it's 10 divided by 32, then times 2, then times 18. So we take 10 divided by 32, then we take it times 2, and then we times it by 18. And we get 11.25. Checking our figures, 1, 2, 3 sig figs, 1, 2, 3, 5 rounding, 11.2, we round to the evens, grams of water. And don't forget about verbiage. If it's on the right, it's produced because we made that. If it's on the left, it's used, but we'll talk about that later. So, yeah, because whenever we're doing a problem, if we're searching on this side, we're going to find something produced with stoich. This side, we're finding something used. So today we found something produced. So to recap, we did grams to moles. It's always 3 steps. Grams to moles. Step 1, do the stoich. Step 2, back to grams. Step 3, grams to moles, do the stoich, back to grams. If you want to do more examples, we'll do a few more in our next minutes video, and then we'll also get into limiting reactants and all that. So there you go, and thank you so much, and we'll see you guys later.